Hello guys, today in this video I'm going to explain the chemical properties of alkanes. This is the part 2 of the alkanes chapter. I have already uploaded part 1 of this chapter, and in that video I have explained about preparation reactions of alkanes. If you haven't seen that video, I will give the link of that video in the description box. So just check that out, and I'll explain those properties which are not that famous in the chemical properties of alkanes, but those are very important in JE mains and advanced also. So just I'll explain each and every concept in detail. For that, just stay tuned with me till the end of the video. Let's start with halogenation. Halogenation is the most important reaction for JEE mains and advanced also, but it's very easy also. Let's see one by one. Let's start with halogenation. Generally, halogenation is a free radical substitution reaction. Here we just replace one of the hydrogen with the halogen, and this reaction takes place in the presence of light. Without light, it won't occur. So let's see one example. Let's see one example. Let's take one alkane RX with any halogen H2. Let's take H2, and in the presence of light H mu, we will get Rx plus Hx. Here we are just replacing this. Sorry, here we should take H. This is an alkane. Here we are just replacing this hydrogen with the halogen. Now, halogen, it may be chlorine, bromine, or anything. So this is an alkane. And this is halogen. In the presence of light, this halogenation will be occurred. Let's see one example like halogenation of methane, special case. Like in this reaction, we will get mixture of products. Let's see one by one. Halogenation of methane. Let's see example for halogenation of methane. Here we, let's take CH4 methane plus chlorine Cl2 in the presence of light. If you take methane as excess, then we will get chloromethane as a product. CH3 Cl plus HCl. And if you take Cl2 as excess, then we will get trichloromethane. Let's see that also. If you take CH4 plus Cl2 in the presence of Hmu. Here we are taking this as excess. So you will get methyl chloride CH3Cl plus HCl. Again we are adding the Cl2. So this reaction will be continuing like this. CH4. Sorry, here we should take chlorine Cl2. Cl2 in the presence of light, you will get dichloromethane. Dichloromethane. CH2Cl2. And then again we have one more chlorine, like we took chlorine as the extra excess. So we will get CH3Cl, trichloromethane. Then finally you will get, here we are taking Cl2 in the presence of Hmu. You will get tetrachloromethane, CCl4. Tetrachloromethane. This way we can get, like, if you want only one product, then we can take alkane as excess. If we want more than one product, like here we are getting methyl chloride and dichloromethane and trichloromethane CH3. Sorry, here it is CHCl3. Here it is CHCl3 and then again tetrachloromethane we got. So this way we have to do this reaction. Let's see the one important thing in this halogenation, that is iodination. Here in this iodination is a reversible reaction because in this reaction HI will be formed as a byproduct. HI is strong reducing agent because, let me explain you in easy way. See, let's take one alkane RH in the presence of I2 H nu. Then what you will get generally Ri plus Hi. This is you will get. But this Hi will be strong reducing agent. So it will again converted to I2. If you keep like this only, this again converted to this I2. So we won't get alkyl halide. Here we should take this HNO3 as oxidizing agent. If you take HNO3, this is oxidizing agent, strong oxidizing agent. So it will reduce this Hi to I2. So this reaction won't go back like for forming I2. This is all about iodination. You should remember in halogenation concept. And let's see reactivity order for halogen. And here Cl2 is greater than Br2 and then I2. Let's see some examples for halogenation. You take cyclohexane plus Br2 in the presence of H mu heat. You will get this as product. Let's see here this question. With this question we will get to know like these type of questions are very famous in JEE mains and advanced also. They used to ask these type of questions. Here they given 2-methyl butane. Here this is butane. 2-methyl butane. You are adding this Cl2 in the presence of light. They mentioned that monohalogenation. So we will get mixture of products. Let's see those out. We have how many types of carbons? Here primary carbons are there, and secondary carbon is there, and tertiary carbon also there. So you will get product as let's add one Cl here. Then again you will get one more product as, let's add one Cl here. Then here also you can add one Cl chlorine, and again one more product is here you can add a tertiary carbon. So now we have to see where is there any possibility to have chiral centers. Here in this one we don't have any chiral center because this carbon has two same groups, methyl groups, and here this is chiral carbon. See here this carbon contains 4 different groups. One is this group, methyl group, and this one, and one is hydrogen. Here also we have 4 different groups. So it has one chiral carbon. It doesn't have any chiral carbon. So how many products we got? This is one. Here we will get two. One is a racemic mixture we will get. So in this we will get two products, and here also two. From this two, from this one. Total how many? Six. Here answer is six. Six products we will get. So let's move to another method, another chemical property for alkanes, that is dehydrogenation. In the name itself we got to know like dehydrogenation means removal of hydrogen. So we will just remove the hydrogen for getting in this breaking of CH bond occurs, then finally we will get alkene as a product. Let's see one example. Let's take propane CH3 CH2 CH3. This is occurred in the presence of light, in the presence of heat. This is also called like pyrolysis. Let's take heat here. If you heat this compound, then we will get alkane CH3 CH double bond CH2. Here, here we have C. You can write this. You can write this hydrogens like this. CH CH. Here we have one more hydrogen. Here we have one hydrogen. So we'll remove this two hydrogen in the form of, it will remove as hydrogen gas minus H2. Then we will get a bond between carbon and carbon. This is the dehydrogenation. And next one is, let's see the another chemical property. Here it is isomerization. This is also important because you should remember the reagent here. If you don't remember the reagent, then even you don't know which reaction it is. So reagent is very important here. Generally in this reaction, less branched chain alkane are converted to more branched chain alkane. Let's see with one example. H3 CH2 CH2 CH3 N-butane we are taking. Here reagent is important, that is in the presence of AlCl3 and HCl and heat. Here this is Lewis acid. Lewis acid, and this one is strong base. You can remember this way also. Reagent, I'll write here reagent again. You should remember this reagent, or else you don't know which reaction it is, because it is a alkane. With this reaction, if you don't know this isomerization, then you won't then you don't get like how to do this reaction. So reagent is more important here, that is Al2O3 in the presence of HCl. This you should remember. Here you will get CH3 CH CH3. As we read here, like less branched chain alkane are converted into more branched chain alkane. See here it is N-butane. Here we got more branched. Here it is butane, and we just removed this methyl group here and we just add here. So branching is increases in this isomerization. This is all about isomerization. Let's see another method, that is aromatization. This is also one of the important thing, because in mains I remember like when I had my JEE mains exam, I got one question from this topic, aromatization, but I don't know the reagent, so I didn't even attempt that question. So you should remember that reagent. A reagent is, we can use The, I'll write useful reagents for this aromatization. Those are Cr2O3 in the presence of Al2O3. This reaction occurs at high pressure, nearly 800 Kelvin temperature. And one more reagent is you can take V2O5 also, or MO2O3 also. You can, if you use these reagents with alkanes, then this will converted into aromatic compounds. Let's see one example here. Let's take an hexane. This you can write it like this for more convenient. Here it is n-hexane. First we are treating with this reagent, that is Cr2O3 and Al2O3. You should remember these reagents. These are very important at 800 Kelvin and at high pressure. So first you will get cyclohexane, then after hydrogens will be removed from each carbon, then hydrogens will be removed in the form of minus 3H2. If you heat this compound, then we will get benzene as a product. So this is about aromatization. Let's move to next concept, that is nitration. Let's see the nitration process with one example. Let's take alkane RH in the presence of concentrated HNO3. You will get RNO, nitroalkane. In alkanes, nitration and sulfonation are not that important because this will give more mixture of products. If you take, let's see one example. With that you can understand much better. CH3, CH2, CH3. Propane. Let's take propane, and in the presence of concentrated HNO3, you will get mixture of products. We will get, here we have primary carbon and secondary carbon. In this reaction, mainly this carbon-carbon bond cleavage also takes place. So this nitrogen of alkane, this nitration of alkane has a very little synthetic application, so we won't use that much. But you should know about this reaction. CH3, CH2, CH2. Let's add NO2 here. Then, and also you will get this product also, CH, NO2, CH3, and carbon-carbon bond cleavage also takes place. You may get this thing also, or CH3, CH2, NO2. In this way you will get many products, so this is not that. So in this way you will get more products. So let's see another method, that is sulfonation. Let's see one example, RH in the presence of concentrated H2SO4. In the presence of heat, you will get alkane sulfonic acid, that is RS43H. In this also, we will get mixture of products. Here in this reaction, carbon-carbon bond cleavage may not occur. In this reaction, if you have different types of carbons, then we will get mixture of products in comparable amounts. If you have different types of carbons, then if you have a different carbons like primary, secondary in that alkane, you will get this products in a comparable amount. So let's see one example with same example as we taken for nitration. Let's take propane. If you add concentrated H2SO4 plus, sorry, in the presence of heat, we will get two products here, because here we have primary carbon and this is secondary carbon. So this say SO3H, we can add it here and here, so you will get two products, CH2 CH3 CH2 SO3H plus CH3 CH SO3H CH3. This is all about sulfonation. Let's move into another topic. That one is combustion reaction. Generally, combustion means whenever this alkanes also, whenever this will react with oxygen, then we will get carbon dioxide and water as a product. Just remember like this, like alkane plus oxygen will give us carbon dioxide plus water. With respect to alkane, we can balance this reaction. For our So let's see the basic form of this reaction. Alkane means its formula CN H2N plus 2, and here 3N plus 1 by 2 O2. We will get N CO2, N moles of CO2 plus N plus 1 H2O. You can remember this form whenever you got combustion reaction, you can balance very easily with this thing. So, but it is whenever you have got like combustion reaction with this form, you can easily balance those reactions. In this combustion reaction, we have some special conditions, like under special conditions partial oxidation takes place. Like from alkanes, we can also get alcohol, formaldehyde and acid also. Let's see one by one. These are all not that important, these are all not that famous, but it's important. in These are the examples which are not that famous, like we won't revise while revising this organic chemistry, but they'll gonna ask these type of questions only, so you should remember these also. Let's see one by one here. If you take methane plus oxygen, you should remember these reagents here. Here copper in the presence of 500 Kelvin or at high pressure and high temperature, you can remember like this. We will get alcohol, methyl alcohol, CH3OH. So in this way, you should remember this thing. It has high pressure also. In the presence of copper and at high pressure and temperature, we will get alcohol from methane. Let's see another example. Here CH4 plus O2, but we are taking different reagent here, that is MO2O3 in the presence of heat. Here we will get formaldehyde as a product. You should remember these reactions, then it's very easy if comes in exam. So let's see one other one. CH3 CH3 ethane in the presence of CH3COO taken twice Mn and heat. This is here Mn. Then we will get acid as a product CH3COOH. And one more reaction is if we have tertiary alkane CH3 CH3 in the presence of KMN4, it may converted to tertiary alcohol CH3 CH3 CH3. So this is all first reactions. Let's see one of the last reaction, that is reaction with steam. Let's take one example like CH4 methane plus H2O steam in the presence of critical heat. We will get carbon monoxide CO plus H2 as a product. This is all for today's video. I hope you have understood all the concepts. If you have any doubt, then just let me know through the comments. I'll go through your comments and I'll clear your doubts. For more videos related to organic chemistry, do make sure to subscribe to the channel and share with your friends. So this is all for today's video. I hope you like this video. Let's meet in my next video. Till then, keep practicing organic chemistry. Bye guys.